In this video, we're going to be talking about linear motion. So in this situation, we're given a particle that's moving up and down the y-axis, and its position is defined by this equation right here. So the first thing, we know we're going to be talking about velocity, acceleration, and speed. So let's get that first. The velocity of any particle is just the derivative of the position. So I'm going to do that first. So if this is the position, the velocity will be the derivative, which is 3t squared minus 12t. I'm going to factor that because that will be useful. That's the velocity. Now the acceleration is just the derivative of velocity, or the second derivative of the position. So you can just take the derivative of the velocity. I'm going to take the unsimplified form, 6t minus 12. I'm going to factor that as well, just because it's probably going to be useful. So now we have, based off the position, the velocity of this particle and the acceleration defined. So now we're ready to answer the questions. To determine the velocity of the particle at t equals 2, that's easy. You just plug in 2 to the velocity. It would be 3 times 2 times 2 minus 4. So the velocity is negative 12. I just used this equation. The acceleration at 2, I'm just going to use this equation. I'm at 2. So it's going to be 6 times 0. So it has a 0 acceleration at 2. During which time intervals is the particle moving downwards? Well, now the direction is only based off velocity. So whenever they ask about direction, if velocity is positive, it's moving in the positive direction, and if velocity is negative, it's moving in the negative direction. So this is asking when this particle is moving downwards. So we're trying to figure out where the velocity is negative, since this particle is moving up and down the y-axis, and downwards would be a negative velocity. So to do this, the easiest thing is to find out where the velocity is 0. That's the only place it could change signs, and according to our velocity equation, that equals 0 at t equals 0 and t equals 4. So we make a chart just like we did when we did the first derivative test, except we're just testing if the velocity changes signs. Really, if you think about it, what you're doing here is you're looking at the derivative. You're looking for mins and maxes of the position. So we'll fill in the blanks here. V of negative 2, V of 2, and V of 10. If you plug negative 2 into the velocity, you'll get a negative times a negative, which is positive. If you plug in 2, you'll get a positive times a negative, which is negative. And if you plug in 10, you'll get a positive times a positive. So we're looking at this equation. It's moving downwards when the velocity is negative. So the answer to this question would be from the interval 0 to 4. Now the next question is to determine the speed. I'm going to change this to t equals 1. Now the speed, no, actually, the speed is the absolute value of the velocity. So we're going to just plug 1 into the velocity, which would be up here, 3 times a negative 3, which is negative 9. And it's just the absolute value, so that's 9. Now, the last question for this video is the speed of the particle increasing or decreasing when t equals 1? Well, To figure out when speed is increasing or decreasing, you just need to know the velocity and the acceleration. If velocity and acceleration are the same sign, the speed is increasing. If they're different signs, it's decreasing. So all we have to do is figure out what the velocity at 1 is and the acceleration at 1. Well, we figured out the velocity at 1 was -9 from up here. The acceleration at 1 from the acceleration equation would be 6 times -1, which is -6. Since these are the same sign, you can then conclude that speed is increasing at t equals 1. So that's the first 5 questions. The last 2 questions I'm going to do in the next video. That involves distance traveled. So I will see you then.